Production PostgreSQL crashed. Memory was still 40% free when it died. The culprit? Linux's OOM killer, a process that murders applications based on a scoring system most engineers never see. This is the case file of why memory overcommit is every DBA's silent nightmare. March 2024. Ubicloud's production PostgreSQL instance terminates at 3:47 a.m. The engineer on call pulls system logs. Out of memory. Killed process 2847 Postgres, but htop shows 6.2 GB free. PostgreSQL had configured shared underscore buffers at 8 GB, well within the 16 GB physical RAM. No queries were running. No connection spike. The OOM killer log reveals a score. Postgres process rated 823 out of 1000 on the badness heuristic. That score determined its execution. The database reserved memory it never touched, and Linux decided that reservation made it guilty. The question: why does Linux kill processes with memory still available? Linux defaults to VM overcommit underscore memory equals 0. Heuristic overcommit. The kernel lets processes malloc memory freely, betting most will never use it. Theory 1. PostgreSQL's shared underscore buffers acts as a giant malloc reservation. 8 GB claimed, maybe 3 GB touched. Theory 2. Fork. For each connection duplicates the parent's address space on paper, multiplying the virtual footprint, even though copy on write means physical pages aren't duplicated. Under mode 0, the kernel tracks both. When a true shortage hits, say, a rogue process actually writes to its malloc, the OOM killer scores every process by virtual size, runtime, and root privilege. Postgres, with its large reservation and dozens of child processes, scores catastrophically high, but Ubicloud found one configuration that eliminates the guessing. VM overcommit underscore memory equals 2 disables overcommit entirely. Total virtual allocations cannot exceed physical RAM plus swap. Typically commit limit equals RAM plus swap asterisk overcommit underscore ratio 100. On their 16 GB test system with 4 GB swap and ratio 50, the hard cap was 18 GB. PostgreSQL's malloc for shared underscore buffers now fails at startup if it can't be guaranteed. No phantom reservations. No surprise kills. The anomaly. Most production deploys still run mode 0 because mode 2 feet wastes memory. You can't oversubscribe, so you need bigger instances. But the trade-off is determinism. Either Postgres starts, or it doesn't. It never starts and dies later. The final evidence sealed the case. Ubicloud's production now runs mode 2 across all database nodes. Since March 2024. 0 OOM kills. A single sysctl line. VM overcommit underscore memory equals 2. Turns silent 3 a.m. murders into loud startup errors you can fix in daylight. That's the resolution. The trade-off is RAM you can't oversubscribe. But for production databases, predictable failure beats mystery death every time. Subscribe to @WhizBros for the next system-level case file. Next up, why TCP timestamps can break your load balancer. Subscribe to @WhizBros. Next case drops Monday.